Children, it is a continuation of the chapter acids, bases and salts. Now let us discuss about washing soda. Washing soda, it is another chemical that can be obtained from sodium chloride. Washing soda is common name of the sodium carbonate, that is sodium carbonate decahydrated. Sodium carbonate decahydrated. So write the molecular formula of washing soda is Na2CO3 10H2O. And commonly you can say it is sodium carbonate, and the common name is washing soda. The chemical name is sodium carbonate decahydrated, or generally you can say it as sodium carbonate. And how will you prepare the sodium carbonate decahydrated or washing soda? You have seen that the sodium carbonate can be obtained by heating baking soda. Here you observe in the reaction when sodium bicarbonate, here you observe this reaction, when sodium bicarbonate, that is sodium hydrogen carbonate, is heated, you will get sodium carbonate. When sodium hydrogen carbonate is heated, you will get sodium carbonate Na2CO3 and plus H2O plus CO2. And here to balance it we have to take 2. Now this Na2CO3 is under the recrystallization. By the recrystallization of sodium carbonate we will get washing soda, that is sodium carbonate decahydrated. So you take Na2CO3 plus 10H2O, which gives Na2CO3 10H2O. Now it is washing soda. It is washing soda, and it is also called sodium carbonate decahydrated. Carbonate decahydrated. So let us write here common name of sodium carbonate decahydrated is washing soda, or chemical name of washing soda is sodium carbonate decahydrated. And molecular formula. Molecular formula of washing soda is Na2CO3 10H2O. Here it is hydrated, it is wet. Know that what does 10H2O signify? It makes Na2CO3 hydrated. Now let us discuss about uses of washing soda. Uses of washing soda. With sodium carbonate or washing soda, generally you can say sodium carbonate or washing soda is used in the manufacture of glass, soap and paper industries. Glass, soap, etc. And it is also used in paper industries. It is also used in paper industries. Here the first one use we have taken in the manufacture of glass. To manufacture glass, washing soda is required, and also to make soap, washing soda is required. Here the word washing is there. It is one of the cleansing agent. Then you take the third one. It is used in the manufacture of sodium compounds such as borax. It is used in the manufacture of sodium compounds such as borax. Then also take one more use. It is used to remove the permanent hardness of the water. You know that the hard water will not produce leather with the soap. It produces scum. And there are many disadvantages of the hard water. So to avoid that disadvantages, we have to remove the hardness of the water. There are two types of hardness depending upon the salt present in the water. And to remove the permanent hardness of the water, you can use the washing soda. So you write that it is used for removing permanent hardness of water. Removing permanent hardness of the water. These are some uses of washing soda. These are some uses of washing soda. Then you take next one. It is sodium carbonate can be used as a cleaning agent for domestic purposes. So as it is washing soda, you can use it for the cleansing purposes. So you can write that sodium carbonate can be sodium carbonate can be used as a cleaning agent for domestic purposes. Children, you do one activity to verify that crystals of salts really dry or not. Copper sulphate crystals which seem to be dry contain water of crystallization. When you heat the crystals, this water is removed and the salt turns white. So you do the activity that take a crystals of copper sulphate in dry boiling tube. Take a boiling tube and take some few crystals of copper sulphate. You know the color of the copper sulphate. Copper sulphate is blue in color. What is the color of the copper sulphate after heating? You notice that water droplets in the boiling tube. Here these are the water droplets in the boiling tube, and these are the water droplets came from the copper sulphate crystals. Add 2 to 3 drops of water on the sample of copper sulphate obtained after heating. What do you observe? Again, copper sulphate turns to blue. Copper sulphate crystals, which are blue in color, are taken in a dry test tube and heated. The water of crystallization deposits on the walls of the test tube and crystal turns white. To show the action of heat on copper sulphate, here you have done the activity, that is, you have taken some copper sulphate crystals in a dry boiling tube. Here what we have observed, copper sulphate crystals which seem to be dry contain water of crystallization. When we heat the crystals, this water is removed and the salt turns white. If you moisten the crystals again with water, you will find that blue color of the crystals reappears. Water of crystallization is the fixed number of water molecules present in one formula unit of salt. 5 water molecules are present in one formula unit of copper sulphate. So you can write CuSO4 5H2O. Chemical formula for hydrated copper sulphate is CuSO4 5H2O because 5 water molecules are present in one formula unit of copper sulphate. Here, then what is the molecular formula of sodium bicarbonate? That you know that is Na2CO3 10H2O. It means one formula unit of sodium carbonate, there is how many molecules of water? 10 molecules of water. 10 molecules of water are present in one formula unit of sodium carbonate. On the other salt which processes water of crystallization is gypsum. Gypsum has 2 water molecules as water of crystallization, that is CaSO4 calcium sulphate 2H2O. The one formula unit of calcium sulphate contain 2 molecules of water. 2 water molecules are present in one formula unit of calcium sulphate. And it is a gypsum salt. Calcium sulphate with 2 molecules of water is called which salt? That is gypsum salt. Now you write water of crystallization. So what is that water of crystallization? It is the fixed number of water molecules present in one molecule unit of salt. So you write that water of crystallization is the presence of the fixed number of water molecules present in one molecule unit of salt. That is in one molecule unit of salt. What is water of crystallization? Water of crystallization is the presence of the fixed number of water molecules in 1 molecule unit of salt. It is a presence of what? Fixed number of water molecules in 1 molecule unit of salt. Example you can take. So you take the example. One example is 5 water molecules are present in 1 formula unit of copper sulphate. 5 water molecule are present in 1 formula unit of copper sulphate. In 1 formula unit of copper sulphate. Then the chemical formula for hydrated copper sulphate is CuSO4 5H2O. Then the chemical formula for hydrated copper sulphate is CuSO4 5H2O. It is a hydrated copper sulphate. Then next you take one more example. 10 water molecules are present in 1 formula unit of sodium carbonate. Here you got that water of crystallization is the presence of fixed number of water molecules in 1 molecule unit of salt. Here we have taken copper sulphate with 5 molecules of water, sodium carbonate with 10 molecules of water, and calcium sulphate with 2 molecules of water. That is water form of crystallization, water of crystallization. Now let us discuss about the plaster of Paris. What is plaster of Paris? It is CaSO4 half H2O. CaSO4 half H2O. Here you know that the gypsum is CaSO4 2H2O and this plaster of Paris is CaSO4 half H2O. On heating this gypsum at 373 Kelvin, it loses water molecule and becomes calcium sulphate hemihydrate. It is half here. Calcium sulphate hemihydrate. Here CaSO4 2H2O is there. When it is heated, you will get plaster of Paris with molecular formula CaSO4 half H2O. What is the molecular formula of plaster of Paris? Plaster of Paris molecular formula is CaSO4 half H2O. And here how will you get plaster of Paris? That is by heating calcium sulphate. By heating gypsum at 373 Kelvin, it loses water molecule and becomes calcium sulphate hemihydrate, which is called plaster of Paris. So CaSO4 half H2O is known as plaster of Paris. This is prepared by heating gypsum at a temperature of 373 Kelvin, that is near about 120 degree to 130 degree centigrade. You might have seen this plaster of Paris, the substance which doctors use as plaster for supporting fractured bone in the right position. So the word plaster is taken here. It is a substance which doctors use as plaster for supporting fractured bones in the right position. Plaster of Paris is a white powder. When it is mixed with water, it changes to gypsum once again, giving a hard solid mass. When wetted with water, this forms a solid plastic mass and heat is given out during this process, and finally a hard porous mass results within 10 to 15 minutes. This involves two steps. Firstly, water is absorbed to form orthorhombic dihydrate and changes to monoclinic. When the plaster hardens, the setting takes place. Here we have taken the molecular formula of plaster of Paris is CaSO4 half H2O. Why is plaster of Paris written as CaSO4 half H2O? How is it possible to have a half water molecule attached to CaSO4? Here the molecular formula, here you observe CaSO4 half H2O. How is it possible? How is it possible to have half water molecule attached to CaSO4? Plaster of Paris is written as CaSO4 half H2O because in this compound two calcium sulphate molecules, that is CaSO4 twice, it attached to one molecule of water. Therefore you can take CaSO4 is one molecule is attached to half molecule of water. Actually, two molecules of calcium sulphate attached to one molecule of water. Two molecules of CaSO4 attached to one molecule of water. Therefore, with one molecule of calcium sulphate, half molecule of water is attached. So, we are taking CaSO4 half H2O. So, you write that what is plaster of Paris? Plaster of Paris is a white powder used by the doctors as plaster for supporting fractured bones in the right position. And what is the molecular formula of plaster of Paris? Molecular formula of plaster of Paris is CaSO4 half H2O. That is, you can write CaSO4 twice H2O. Actually, two molecules of CaSO4 is attached to one molecule of water. Generally, we can take it as CaSO4 half H2O. Then, take the preparation of plaster of Paris. Preparation of plaster of Paris. So how will you prepare? On heating gypsum at 373 K, it loses water molecules. It loses water molecule and becomes calcium sulphate hemihydrate. Hemihydrate, which is called plaster of Paris, which is called plaster of Paris. The general formula is here. General name is plaster of Paris and the chemical name is calcium sulphate hemihydrate. Calcium sulphate hemihydrate. That is the chemical name of the plaster of Paris. General name is plaster of Paris. So you can write that on also. Chemical name of plaster of Paris is calcium, right here, calcium sulphate hemihydrate. So then you take general name of calcium sulphate hemihydrate is plaster of Paris. Plaster of Paris. Plaster of Paris is a white powder and on mixing with water it changes to gypsum again. On mixing with water it changes to gypsum, once again giving a hard solid mass, that is CaSO4 half H2O. When it is mixed with water, you take 1.5 molecule of water, gives CaSO4 2H2O. This is plaster of Paris and this is gypsum. Here when it is dehydrated, when the gypsum is dehydrated, you will get the plaster of Paris. Again when this plaster of Paris is hydrated, you will get the gypsum. So you write that plaster of Paris changes plaster of Paris on mixing with water it changes to gypsum once again. gypsum, once again giving a hard solid mass gypsum. So this is the reaction what takes place when, because of the setting property of plaster of Paris, it is used to making chalks and fireproof materials and used for making patient plasters used to surgery and for plastering fractured parts of the body, and it is mixed with alum and used as a cement in ornamental casting and for making molds in pottery works, and also it is used in making toys, materials for decoration and for making surface smooth, and its facial property is setting. When wetted with water, this forms a solid plastic mass and heat is given out during this process, and finally hard porous mass result within 10 to 15 minutes. This involves two steps. Firstly, water is absorbed to form orthorhombic dihydrate and change to monoclinic. When the plaster hardens, the setting takes place. The setting property of plaster of Paris is a special property which can be used to manufacture the idols, toys and other materials. So you take the reason to show only half a water molecule is shown to be attached as a water of crystallization. So you take only half a water molecule is shown to be attached as water of crystallization. How is it possible? How water molecule becomes half here? How is it possible? So here only half water molecule is shown to be attached as water of crystallization. How is it possible? Because you know that no existence of half molecule of water, but here we have taken half molecule of water. Here we have taken half molecule of water for the plaster of Paris. How is it possible? So here actually it is written in this form because two formula unit of CaSO4 share one molecule of water. The molecular formula or chemical formula of plaster of Paris is CaSO4 half H2O, because two formula unit of CaSO4 means two molecule of water, two molecules of plaster of Paris. Two formula units of CaSO4, two molecules of CaSO4 share one molecule of water. Share one molecule of water. Two formula units. So you take here, because two formula units of CaSO4, two formula units of CaSO4 share 1 molecule of water. One molecule of water. 2 molecules of CaSO4 share 1 molecule of water. That is CaSO4 twice H2O. But here we have taken, for 1 molecule of CaSO4 we have taken half H2O. Then you take uses of plaster of Paris. Uses of plaster of Paris. It is already discussed that doctors use plaster of Paris for plastering, and that is as plaster for supporting fractured bones in the right position. That is the main use of the plaster of Paris. It is used for the plastering of the fractured bone, to keep the fractured bone in the right position. And also it is used to make the toys, idols and other materials, decorative materials, and also to make surface smooth. So you write the uses one by one. First you take plaster of Paris. Plaster of Paris is used by doctor as plaster for supporting fractured bones, in the right position. Then you take, it is used for making toys. It is used for making toys, materials for decoration, and for making surfaces smooth. Making surfaces smooth.